This episode of Raw Green is brought to you by OBI, a sustainability consultancy firm specialized in life cycle assessment and decarbonization strategies. At OBI, we've designed our new Chief Sustainability Officer package to empower SMEs with comprehensive ESG solutions at a fraction of the cost compared to traditional solutions. Our entry package includes a full ESG report covering scope 1, 2, and 3 emissions, a tailored emission reduction strategy, access to GRI certified software, and more. What sets us apart? Affordability. Our goal is to make sustainability accessible to businesses of all sizes. Contact us for a free consultation at info@oneob.com or through the links provided in the description. And now, get ready for the next episode of Raw Green. Ciao! Welcome to a new episode of Raw Green. I usually start every episode of Raw Green by giving context on the technology, industry, or research study we will be discussing. This time, I would like to start by addressing stupidity, idiotic idiocy, a lack of long term perspective, inconsistency, and ignorance. Lots of ignorance. The subject of my rant is the Italian government. Last week, the Italian government released a new futuristic decree banning solar PV installations on agricultural land, which, according to a report from Italia Solare, could translate to a loss of more than 60 billion euros, not to mention loss of income for farmers on non arable agricultural land. Besides the economic opportunity losses for a country with a debt to GDP ratio of 137%, literally the week before, during the G7 in Turin, it was agreed to triple the installation of renewables and phase out coal by 2035. There could have been a million ways to handle the fear of losing agricultural land for the purpose of developing clean energies. But it seems like it doesn't matter which side of the political spectrum the Italian government falls on, whenever something is working well, they have to destroy it. Luckily, there is one thing that hasn't been included in this decree and is growing in interest globally: agrivoltaics. This innovative approach combines agriculture and solar energy, offering a win win solution for both clean energy production and supporting farmers. With climate change causing unpredictable weather and rising costs that threaten the farming sector, agrivoltaics can be a game changer, providing a new source of income while helping us reach our decarbonization goals. The guests we have today are experts on the topic, and both from the University of Natural Resources and Life Sciences in Vienna. They recently published a paper analyzing the environmental impacts of various agrivoltaic technologies and comparing them with the mono use of agricultural land. I'd say the timing of this episode couldn't be more perfect. Welcome, Theresa Krexner and Alexander Bauer.
Hello, thank you for the invitation.
Thank you for being here, both of you. First time we do an episode in three. Let's see how this goes. So, Alexander, Alexander, first question that I would like to ask you. Let's start from the basic. What is agrivoltaics?
Yeah, agrivoltaics, there is not a 100% clear definition, but in general, it's the utilization of agricultural land at the same time with the production, for energy production without competition or with try to reduce the competition between the two different ways of utilization. From my point of view, it's important not to do only agricultural on the arable land or on the land. It's important to do the same as we did before. So it's important to do the agricultural production in the same way or in a similar way as we did it before, not changing the products producing on the land, not changing a lot of, not changing um, the productivity or decreasing the productivity of the agricultural production.
Wonderful. And let's say this it is a wonderful solution that could help with both, and it is not something new. Let's say the attempt to put together energy production and agricultural farming, it has been done. I remember a project I've seen over 15 years ago of solar greenhouses in Sardinia. It was an amazing project. It was fantastic. But it is in the past, let's say, 3 4 years, that it is gaining also that commercial interest because of the decline of costs on solar installation. Hence, it makes a little bit more viable. Now, both of you did published a wonderful research. It is a life cycle assessment that compares different technologies of agrivoltaics versus the mono use of agricultural land. Teresa, why don't you give us an overview of your research?
Yeah, sure. So, as you said, we did a life cycle assessment of agrivoltaics. We actually had two different goals in mind for this paper. The first one was to compare two different APV systems. The stilted one, where you stilt up the PV modules and then you do the agricultural production underneath, and the vertical bifacial APV system, where usually the PV modules are mounted vertically, usually two on top of each other, and then the agricultural production is done in between the PV rows. So that was the first goal, like to compare these two different systems. But then we also thought, like, the usual way of using agricultural land is actually the agricultural production, this mono use of land. And then we thought, let's compare it also with another like extreme of mono use of agricultural land, which is if we would use this agricultural land just for a common PV plant. And that was the whole idea of this paper.
Okay, so stilted and vertical APV compared to the mono agricultural land, and what is what is the unit of reference that you use? What is like a kilowatt hour, a kilo of crop harvested?
That's an interesting question. That was actually quite complicated because we wanted to analyze the APV system as a whole. So we wanted to include both the electricity production but also the agricultural production, because we think that's kind of what makes agrivoltaics so unique. It's not only electricity production or only agricultural production, it's actually both. So we were
Double
actually
output.
looking
Yeah.
for a way. Yeah, exactly. It's a multi output. So we were actually thinking, or like trying to find a way of how can we put both these outputs in a functional unit. And but then we also have this challenge that we compare different scenarios, and two of them are just mono use scenarios: the agricultural production only and the PV electricity production only. So we actually came up with a system expansion approach, and our functional unit is actually 1 kilowatt hour of electricity plus a basket of agricultural goods. So now it really includes both the outputs.
Okay, which when you say system expansion, what does that mean?
Well, when you have multi outputs in LCA, there are different ways to handle them. Actually, in the ISO 14044, which is one of the ISOs the life cycle assessment is based on, there is actually a hierarchy of how to deal with multi outputs. And the first one is actually, well, just divide the environmental impacts. And something that might be also a possibility for agrivoltaics, but we've seen already that, you know, the PV modules, they shade the plants, so there is actually an interaction. And also I've seen studies where actually the plants underneath the PV modules, they also have an influence on the PV modules. They actually can cool them. So we thought, okay, we don't want to just divide them, the environmental impacts, because we think there is this well,
Mutually
connection between the
beneficial.
PV modules
Yeah.
and the plant. Yeah, exactly. So, and
Yeah.
then the next step in this hierarchy is actually system expansion to avoid allocation in the ESO, and that's why we use this approach.
Okay, that's very very interesting. And let's cut to the chase. What are the results?
Well, first of all, we have to see our results based on the assumptions that we made, and we started the project actually by the end of 2020. So most of our assumptions are made at that time. So to be honest, some of our assumptions are already outdated, because you pointed it out. Agrivoltaics is now like highly researched, and there's so much going on in this field. But back to the results. Well, we found that actually with agrivoltaics, we can decrease the environmental impacts compared to a mono use, especially compared to a mono use of agricultural production, and then with an additional electricity production of Austrian electricity. And we also
Hold on, hold on,
found that
hold on,
the
hold
vertical
on.
bifacial.
Time out. Time out. Were you saying that the APV system, the APV system has lower environmental impacts than the piece of land with a mono production on top?
Yes, but due to the system expansion, you not only have this agricultural production, but to have a fair comparison between the scenarios, you actually have to, well, that's the name, you have to expand the system, and then you have to include an additional production chain of electricity. So then in
Hmm.
every scenario, you're really producing the same amount of like outputs. The agricultural good and the electricity. So for the mono use of land, just this agricultural production, it would be a super unfair comparison to compare it with like agrivoltaics, because there you have the PV modules, you have the mounting
Yeah.
structure. They're highly intensive for producing, So that would
Yeah.
be super unfair. So that's why you do this system expansion, and for the mono use of just the agricultural production, you do the system expansion with this additional production chain of electricity. And there,
Yeah.
because we know actually from literature that the electricity production can have a very high, can influence the results. So we actually looked at a production chain, which is the Austrian electricity production, but then also just at green electricity production. So really electricity just produced from wind and water energy.
Yeah. Well, now I don't know what was in 2020 the energy mix, the grid intensity. Sorry, in the Austrian grid, but I checked it out the other day, and as of now, it's like 170 grams. The past 12 months,
Yes.
170 grams of CO2 equivalent per kilowatt hour consumed. Okay, okay, that's interest. That's interesting. And so, among the two, which one among the two APV, which one it is the one with the least environmental impacts?
This was actually the vertical bifacial APV system. And this was actually due to especially one reason, because the stilted APV system, we looked at one that stilts the PV modules up to like 4.8 meters. So imagine you need a lot of steel, especially because there is wind, there is snow, and of course it has to be like safe to withstand this wind and
Yeah,
snow or whatever. So you actually need a lot of steel, and the vertical bifacial system, it's maybe around 3 meters high, so you need definitely less steel, and that was actually the main reason why the vertical bifacial APV system has less environmental impacts, actually in all the impact categories that we had a look at.
okay, okay. Well, look, it makes sense because yes, you have much more materials in your inventory between the two, which probably would still be to be accounted for in any various end of life treatment. Doesn't matter of the two. That wouldn't change the final outcome. Okay. And we were talking before about the relationship that there is between the agricultural activity and the energy production, between the plants and the solar modules. And we were chatting about it before, and there is this beautiful case study of a wine association in the south of France that run a test on APVs, where basically, thanks to the shading of the solar modules, there was a water retention in the land, on the soil, that helped save 34% water consumption for the vineyards, which was phenomenal. It was fantastic, especially when you start to hear from now until October of droughts and places like Spain and Italy and France too, Germany too. Last year there was a lot of issues with droughts. So when you start to hear stuff like that, it is a good news. Now, what do you think, and how important it is the crop selection into the APV? Given this relationship, how important it is to match the two things to optimize the double output that you studied in your research?
Yeah, the question it's not easy to answer because it's as you mentioned before, in Spain or in France we have other conditions as we as in Austria, as we as in Germany. So it's extremely difficult to say what it's the right crop or the right plants growing below AKPV. We have the conditions here in Austria. It's not so extremely hot as in Spain. We have many regions where we have not unlimited water, but we have enough water for producing in a good condition. But we see also in Austria, and we have running a project since 2 years, where every year shows us completely different influence of AGPV on the crops. For example, we had last year the cultivation of sorghum, and sorghum as a C4 plant, it's reacting extremely strong on less radiation. So the yields are going down, and especially the biomass yield was extremely low in comparison to the control. And we have this year the opposite when we are cultivating, for example, wheat on the fields. We see that the wheat it's growing much better between the rows as in the control field. So we see at the moment we have higher yields. The plants have more biomass, and they are growing better, especially because this year we had a really hot spring already in March. We had high temperatures, and the plants are reacting on these conditions. So it's therefore, it's important when we are speaking about AGPV not to look only on one specific field, on a specific location, on a specific crop. We have to look on the whole system, on the agricultural production in crop rotation systems over some years. We have to integrate also the influence of the weather conditions to see which are the best conditions for growing below agri-PV systems. And from my point of view, in Austria, we can have we can have positive effects from the agri-PV systems, especially when the weather conditions are not as we are used to it. So they are changed. If the temperature are higher, if the rain is missing, we expect that agri-PV is causing higher yields below AKPV modules in comparison to systems without shadow, without AKPV PV systems, and can help to make a sure income also for the farmers.
That's very important. There's a triple output, which is also the social part. It is not just
Exactly.
energy. Yeah, it's not just energy or crop. There is also that social part that it is very very important. Very, very important. Look, Teresa, you mentioned before, obviously, that it would not be fair analyzing the comparing, sorry, the APV with the mono agri-land because obviously of the vast amount of materials. And among the most important material are the solar modules. And in your study, you run your sensitivity analysis specifying the impacts that have the modules produced in China. What would be the difference if you were to produce or use modules produced in Europe?
Well, we actually found that the environmental impacts for nearly all the impact categories that we assessed would actually decrease. Um, well, we took this assumption that the PV modules are produced in China because that's just state of the art. Still, the majority of PV modules are produced in China. But then we thought, okay, what would happen if we would produce them in Europe? And we found this decrease of impacts. And the European electricity mix is not even like that green, you know. So I think there is still the possibility to even decrease the environmental impacts even more, especially if you would just use a green electricity mix, which should be the ultimate goal, I would say. So there is still, the possibility to decrease impacts, definitely.
What is the part of the modules that impacts the most?
It's the wafers because it's super electricity intense to produce them.
The wafers, okay.
Yeah, so this. I mean, we assumed that we use monosilicium PV modules, and there, you need a lot of electricity to produce the silicium to the wafers. So yeah, it's highly electricity intensive, and then of course it truly matters where the electricity is coming from.
Okay. Well, so that will be a case where some EU protectionism could be of help in reducing, let's say, the final CO2 emissions per kilowatt hour produced in this case using
Definitely.
EU made modules. Interesting. And what would you suggest to if you were more involved at political level? Okay, you heard my rant at the beginning, and I really had to hold it because there were lots of swear word involved that I had to cut out just to make the podcast available to a broader audience. But you heard that the Italian government is doing this incredible things in a moment where you have to take the exact opposite direction. But what would you suggest to EU legislators that to be implemented right now as a policy to push the deployment of APV faster to increase the adoption rate?
Well, I think we have to force also the legislation or the states to see the needs also, that we have to find out what is the right technology for the future. And we know already from many studies, publications, that it's important to have different technologies, especially different ways of production of electricity, to have a safe basis for producing, for be safe and independent also from other states. And therefore, I think we have also to analyze the possibilities of PV. And we know, for example, from Austria, that we have only limited potential to put it on the buildings, the PV modules. We have to go also in open land. We have to go in land not used for agriculture, but we have also to use agricultural landscape or like agricultural areas for producing electricity. So I think it's necessary that it's also from the research or from the politicians are forced to produce or to install EGPV plants, to have also available the land for agricultural production at the end, especially in the context of the changed climate what we have in Europe. And AGPV can also be a potential technology. It's not clear at the moment how big the effect on the microclimate is. But from the first results, what we see worldwide, we see that AGPV is influencing in a positive way the agricultural production, can save water, can reduce wind speed on the agricultural land, can reduce erosion, can reduce extreme weather effects on the crops. So it's not going to be so extremely hot as in an open area without shadow. So the AGPV is, or the PV modules are making some shadow on the plants. And therefore, may it's also technology for helping us to be on the safe side when the climate change effects are influencing our agricultural production strongly.
Amazing. And yes, yesterday I was reading an article of optimization of APV, that now you have transparent or semi-transparent modules where you can arrive to a level of tuning where you can basically adjust the kind of glass to the perfect wavelength, that it is the best wavelength possible for that particular crop, that it is at the bottom of the, this is for the stilted APV, yeah, for that crop that is at the bottom of the APV system, which is fantastic. It's absolutely amazing to have something like that at disposal with so many benefit on the site. So amazing. In your study, you talk about higher energy density and higher crop yield. How those two parameters can affect the final outcome, the final results of your study?
Let me start with the agricultural production. So we've seen that actually the agricultural part does not have that much of an influence on the environmental impacts. Like the relative impact is, it's not negligible, but the PV part actually plays a higher role. So of course, if you would have higher outputs, the relative impacts would probably be a little bit lower. But I think we should more focus on the PV part, and there, if you have higher energy density, because that was actually one of our limitations in the study, we assumed a very conservative energy density for our two APV systems, especially for the stilted one. So that's why I said before that we started the study in the end of 2020, and we took a quite conservative approach of how much watt peak the PV modules have, especially for the stilted APV system. So we assumed 210 watt peak, which is quite low, and I would say nowadays it's much higher. And I did a little bit of like trying to get some preliminary results. What would happen if we would have like 360 watt peak or even higher? And then the environmental inputs would decrease a lot. So I
Yeah.
think, especially for the stilted APV system, the goal has to be put as many high watt peak PV modules on there, and then try to decrease of how much steel you need. And I think then it could be, well, very much compatible with the vertical bifacial APV system, definitely.
Oh, really? So you're saying that with a more increased energy density, with a higher energy density, the stilted one can get closer, not the same, can get closer to the vertical bifacial.
Yes.
Wow. And
Yes, it could
offset the
be.
steel.
Yeah. Yeah, I mean, you always have to keep in mind we did the study also for Austria, and I've already heard about vertical bifacial systems that need more steel if they're, for example, next to the sea, and there is like a much higher wind speed, and then you even for this vertical bifacial APV system, you need higher steel demands. So it's like very location specific. But I think for the Austrian case, where we don't have these super high wind speeds, yes, it could get, well. not maybe exact the same, but the environmental impacts could get close to the vertical bifacial APV system. Yeah, definitely. Especially when you use also bifacial PV panels. Because for the vertical bifacial APV systems, because the PV modules are vertically mounted, you usually use bifacial PV modules so you can produce electricity on both sides. And back when we started for the stilted APV system, that was not state of the art, I think, because back then also bifacial PV panels were still more expensive. But now it's actually also more and more getting to stilted APV systems that they use also these bifacial APV systems, this bifacial PV modules. So this could also like help in even have higher electricity output. Yeah, definitely.
Well, look, I have seen so many, and they're all beautiful. To be honest, they're all super fascinating. The vertical bifacial, I've seen guys that they put greenhouses with the plastic film, but it is a high reflecting plastic film. So basically, you have a double radiation, one from the sun and the other one from the reflecting of the light from this greenhouse, from this film, which is fantastic. The other one was tilted but with tracker, and okay, we know about trackers. What it is fascinating, it is what happened underneath that. That you have basically three different areas of radiation underneath. One that got, let's say, lots of irradiation during the morning and shading in the afternoon. So you could choose that particular type of crop. At the center, you're having the most sun radiation, so you could grow crops like tomatoes or peppers. And then the other one, the other way around, so you have no sun in the morning but lots of sun in the afternoon, which is good for crops like eggplants or pumpkins. It's fascinating, fascinating. Then that opens up so many possibilities, and also gives so many alternatives, not to mention energy security also for the farmers. I met a couple of days ago, a couple of weeks ago, a very, very, very interesting gentleman that is a board member uh, for a agri-robotic company. They're building a special machines, special robots that are able to pick very complex fruit or vegetables. I don't know, imagine like raspberries without destroying them, raspberries or strawberries. So there is also that part where also the agriculture, it is going towards automation, it is going towards electrification as well, and to be able to get your own source of energy directly from the field like a crop, it is pretty amazing. It is pretty amazing. Look, we Alexander, we were talking about before the, let's say, the double, but that in reality it is a triple output of having APV system, which is obviously the energy production, the agriculture, but also the social one. What do you think could be the social repercussion from the deployment of large scale APV plants across EU?
Well, this big farms or this big AVPV plants, they can have really many benefits for the people living in the countries. But it's not clear at the moment, or the people are really skeptics also regarding this big plans. So from what we are trying to do, it's also to show the people the advantages from these big AVPV systems, what it's possible to do, why it's necessary to do, because for many it's not clear why we need these AGPV plants on the fields, and why we should really accept this technique installation on arable land if we have other streets or houses where we can install also PV plants. So I think it's necessary to give the people or to take it into the system in the to give them the information regarding to the necessity to install these APV plants. From my point of view, it's extremely important to see also the benefits from this, from the production of the electricity in the regions where we need electricity, to be also a little bit more independent from the grids, to be independent from the import from electricity, to produce the electricity what we need um, immediately. And we should also, and it's also a point regarding the tracking system, what you were mentioned before, we need also to having systems to produce the energy in the moment when we need the energy. For example, with the tracking system, we can use the radiation from the sun for producing crops in the moments when we don't need the energy on the market, because we can change the position of the modules that the sun is going on the ground, and the crops can produce more biomass. And when we need electricity, we can change the position to maximize the electricity production, and lose may a little bit on biomass yields. But it's a possibility to bring together the food production and also the electricity production, because we are used to have both of them. We need electricity and we need also the food, and we want to have it always, and we are not used to wait for something. So it's also something what from the social side, it's really important to take into the account when we are speaking about AGPV system.
Thank you. Yeah, interesting. It is definitely something where I will put lots of efforts into it. I don't see any losing part into this, except maybe for the part where, due to the, let's say, higher inventory of materials, the cost of installing per kilowatt, it is higher than a normal solar PV, for sure. But you also have the social part that in theory should have set at legislative level, at government level, at country level, that should be offsetted uh, by far a lot. But anyway, look, I wanted to thank you, both of you, for participating into this episode. What's next, Teresa? You said something before that you keep. You thought I was not going to ask that.
Well, there's so much to do. But well, our LCA so far was just cradle to gate, and now, of course, to like assess the full life cycle, I'm currently doing research on the end of life of agrivoltaic systems. And well, that's kind of also like my methodological focus in my PhD, like this, how to handle multi outputs. And there are different approaches how to handle end of life. And there are so many approaches in LCA out there. And I want to compare different end of life approaches of how they influence the results of the whole agrivoltaic system, if I really assess the whole life cycle with different end of life approaches. So that's next.
Nice. What about other materials rather than steel for the stilted?
Yeah, well, I heard about some rope systems. They use definitely
Hmm.
less, still steel, but less steel, and they also use some ropes. I also heard about one project that they tried wood, but then the wood has to be really, withstand the outdoor conditions. So not sure if it will work out, especially for the very high stilted APV systems. But that could be something really interesting to look in. Yeah, definitely. I mean, as we said before, like there's so much research going on about agrivoltaic systems, like with creative solutions. So probably when I'm done with my end of life research, I have like 3 or 4 other possibilities to assess with LCA.
Nice.
So it's interesting. Yeah.
Nice, wonderful. Well, thank you, Teresa. Thank you, Alexander, for participating, and I look forward reading your next research.
Thank you too.
Pleasure.
Thank
Bye.
you.
Bye.
Bye.
Thank you for joining us on this episode of Raw Green, brought to you by Obi. At Obi, we have designed our new Chief Sustainability Officer package to empower SMEs with comprehensive ESG solutions at a fraction of the cost compared to traditional solutions. Our entry package includes a full ESG report covering Scope 1, 2, and 3 emissions, a tailored emission reduction strategy, access to GRI certified software, and more. What sets us apart? Affordability. Our goal is to make sustainability accessible to businesses of all sizes. Contact us for a free consultation at info@oneob.com or through the links provided in the description. See you at the next episode. Ciao.